Aligning curriculum. This is Patricia Nero from the American College of Education. I am a current student there, and this is my capstone requirement for individual project. In this presentation, I will be showing you how to align curriculum by unpacking a standard. This is making sense of standards for new educators or student teachers. For some background information, again, my name is Patricia Nero. I am a student at the American College of Education. I am a master's student. I am trying to obtain my master's degree in STEM leadership. My goal is to one day be a department chair or a curriculum and instruction chair in which I help educators set curriculum, define standards, and essentially unpack those standards so that they can successfully teach all students. For some background about standards in the United States and about curriculum in the United States. Education in the United States is typically defined by the states. Each individual state has specific standards that it adheres to. Some states have decided to group together to specifically adhere to some standards that we'll go about in the next slide. This really did happen, though, during President Bush's era with the No Child Left Behind Act. The idea was that every student would receive a good education, no matter what state they're from, what area of the country they are from. So in order to incentivize this, funding became more regulated, and student success determined that funding. So students were meeting current objectives, standards, that funding was then passed on. And also regulated and passed to specific states or areas that would need more funding and more assistance. Another interesting fact is the inclusion now of the EdTPA in many states. The EdTPA was introduced in 2013. I was part of some of the newer students that had access to EdTPA. And in the NTPA, you have to show mastery of students through the use of standards. So you also had to unpack a standard, you had to explain your lesson, your units, using standards, and also showing how you can make improvements. This was fully enacted in 2015, 2016, and is now implemented to some degree by 35 different states in the country. For the standards in the United States, there are some specific standards that help each different subject area map out a true curriculum. For my English and mathematics teachers out there, that is Common Core State Standards. I am most certain that you have heard those standards before. You are much more familiar with them than I probably am as a science teacher. Those standards are broken down by areas and by specific achievements such as nonfiction, fiction, literature, for mathematics, probability, statistics, geometry, and algebra. The standard that I'm really going to look at come from NGSS though. NGSS is the Next Generation Science Standards. These are the standards that I am most familiar with, being a science teacher who has taught biology to juniors because it was a flipped system at the high school that I taught at, and also all of middle school science standards. Science does align to Common Core state standards in regards to informational texts and citing evidence using those texts. Those are specific standards that are usually very limited. We only reference them on occasion. They're more like our secondary standards. For history, there's also the Common Core state standards. I find that history is much more diverse according to the specific states. For example, the state that I currently teach at is Illinois. Illinois has its own standards for social sciences. It's called the Illinois Learning Standards for Social Sciences. So this is a varied approach that is specific to the individual states. Now, you may have noticed that I don't have art, I don't have music, I don't have early childhood up here. That is because those are outside of the core. So the 4 core classes that all of our students take are English, math, science, and social sciences. And that is for K all the way through 12. Now that being said, obviously art, music, they're important to our whole student and they should be implemented in schools. There's just not specific standards that, for example, will be used in Danielson. Danielson is an evaluation system that many educators will have to know and be familiar with. Part of Danielson is looking at mastery, is looking at something like a MAP score. So high stakes standardized testing, looking at those scores and determining success. So these are the standards that are in the United States currently. They are implemented by the state of Illinois, in which I currently teach. Now to look at NGSS in further detail. So when you're unpacking a standard, when you're trying to figure out how you're going to create a curriculum, you first have to pick a standard. That seems the most obvious, but that's because it is the most obvious. It's the thing that we need to pick. Now, for science, like I said, it's next generation science standards. And the idea here is that we're working with something called backwards design. Backwards design is simply working backwards. So you're trying to figure out, okay, what do I want the students to know at the very end of my unit? What do I want the students to walk away from? With that, you have a standard, and then you can start breaking it up. The standard that I picked up for this example is evolution, which I know that many people have biases, there's conflicting arguments about evolution, so what better way to present how we can unpack the standard than with something that our students will definitely find controversy, have misconceptions with, and need to understand in further detail. So the standard that I pick for this specific demonstration is communicate scientific information that common ancestry and biological evolution are supported by multiple lines of empirical evidence. That is a mouthful. Simply spoken, that is a mouthful. So in order to break this up, first let's look at our verbs. So communicate. So communicate, we can think of it as a writing. We can think of it as an oral presentation. We can think of that in many different ways for our students. It doesn't necessarily have to be them talking. It can be them taking a test and them writing how, for example, DNA supports the theory of evolution. So we have that verb, we have communicate. Now let's look at scientific information. So scientific information, this is information that is from science. So they're going to need access to some kind of scientific article or something that has been peer-reviewed and supported from different professionals. Common ancestry. So this is going to be one of our big concepts that we teach is common ancestry, the idea that we have common ancestors. It's not that humans evolved from monkeys, it's that there was a common ancestor through which we evolved from, and that there is ultimately the first common ancestor that began everything. Biological evolution. So that is evolution through biology. So that is us evolving as a species. Individuals do not evolve, species evolve. That's one of the first things that I teach my students when we're undergoing evolution, when we're learning about natural selection. They tend to think that this is an individualized thing. It's not. It is species are evolving, populations evolve. Okay. Now supported. That's our next big one, supported. So we're going to have to show them how they can cite evidence. So this is bringing in our Common Core standards, the secondary standards. How they're going to support what they write, their reasoning, through different evidence. And that's our next big important part of the standard right here is multiple lines of empirical evidence. So multiple lines, they can't just use one piece of evidence, they need to use multiple different pieces of evidence. So the good thing about NGSS is that they have clarification statements, and that is up on the slide for you to see. Emphasis is on conceptual understanding of the role each line of evidence has relating to common ancestry and biological evolution. Examples of evidence could include similarities in DNA sequences, anatomical structures, and other of appearance of such structures in embryological development. So that means looking at embryos and comparing them, anatomical structures, looking at homologous structures and analyzing them. One of the classic examples is looking at the ulna and radius in humans and comparing that to cats, dogs, bats, whales, etc. That's usually grouping all mammals together and trying to figure that one out. So also another thing that NGS does is it breaks it into 3 different groupings. So there's the science and engineering practices, how they can participate in that way. Disciplinary core ideas, cross-cutting concepts, so involving different concepts in there, such as the nature of science, such as genes, different phenomena, trying to understand. So this is how NGSS breaks it up. I always find that NGSS breaks up standards very well, very efficiently, and I can usually easily unpack a standard from NGSS. If you are a math teacher, if you are an English teacher, this may be more difficult for you. I am not sure on how to unpack the standard from that perspective, and I would love to learn them. So now that we have looked at the standards, let's see what the students need to know. The emphasis is on the conceptual understanding of the role each line of evidence has relating to common ancestry and biological evolution. Okay, so that means that they have to understand the concepts of evidence. So they have to understand, for example, DNA sequencing. So that, if you look at to the right on the slide, number 2, connecting DCIs and CCCSs, students identify and communicate evidence for common ancestry and biological evolution. So information derived from DNA sequences. So they have to understand DNA. They have to understand what DNA looks like. They have to understand what DNA is being used. They have to understand base pair, complementary pairing, etc. They have to understand gene sequencing. They also should know basically central dogma and DNA to RNA to proteins. So the creation of amino acids that lead to a specific protein that is folded. So if they do not understand that, that unit should be taught first, so to speak. What does that mean? That means that this particular standard, especially for students who struggle with writing or with reading, this standard should be later in development. For example, at the high school that I used to teach at, this standard was last throughout the entire year. Students learned about DNA, they learned about structure and function, they even learned about transfer of energy and interdependent relationships in ecosystems before they learned about evolution and natural selection. That being said, students who are higher in reading, have higher lexile scores, they may actually find this as intriguing and a way to delve deeper into DNA. So this could be an introductory piece, which is what my high school did for AP Biology. This was actually the introductory piece. So we've broken down the standard a little bit in more detail, but now we have to really understand big ideas, enduring understandings, and the essential questions that we want our students to explore. So, enduring understandings. So there's 3 major ones that I have concluded based on what I've read from the standard. Common ancestry and evolution are supported by DNA evidence. There are clear, distinct patterns from fossil records that can be used as evidence. Anatomy and embryology can be used as evidence. So that's the enduring understanding that I see coming in here, and then here's an enduring understanding statement. Students can demonstrate an understanding of the processes that change the distribution of traits in a population over time and describe extensive scientific evidence ranging from the fossil record to genetic relationships among species that supports the theory of biological evolution. So they're using evidence to support evolution. This evidence is coming from DNA, it's coming from embryology, anatomical structures, the fossil records. And here's something. Students can use models, apply statistics, analyze data, and produce scientific communications. That part can be used for anything. Those skills are essential no matter what you're learning about. And it's good to include that in your enduring understandings. You want students to be able to use models. You want them to apply statistics, analyze data, and this is in any subject area. This can be for social sciences, this can be for English, this can be for mathematics. This isn't specific to just science. This is an enduring understanding that they can take with them to a future job career. That's why enduring understandings are really important for teachers to have. You need to have enduring understandings. You need to be able to say, okay, at the end of the day, what do I want my students to take away with? What do I want them to be able to know and truly grasp when all is said and done? Because I can guarantee you, they're not going to remember everything. I think even as a new teacher, you know they're not going to remember everything. There's a good chance that they will not know how to use the quadratic formula once you leave your classroom. There's a good chance that they won't know who that author was who wrote A Telltale Heart. They're not going to know that, but they're going to know how to read a text and understand main ideas. They're going to know how to apply information such as adding or subtracting to find out, okay, how much do I have left in my bank account if I were to buy something? What is the interest rate on a house? What mortgage values? Stuff like that you want them to be able to take away with. And that's essentially what school is about. It's about learning how to apply your skills, build these skills, use this knowledge later in your life. So this is essentially a trial run for them. When you're presented with new information, how do you make sense of the stuff that is real and supported with evidence and the stuff that isn't supported with evidence and is used in popular media because it sounds fun? Especially with today's students, that is a very horrifying reality, is that they are presented with a ton of information and they have to make sense of all of it. So part of this unit is to teach them how to make sense of it, how to remove the facts from the misconceptions. So that's the enduring understandings, and that ends up breaking this up into our essential questions. So now that we have explored enduring understandings, we are going to explore essential questions that have come from this unit. As you work backwards, you start with the standard, which is the overarching idea that will govern your unit. Then you go into enduring understandings, what you want the students to take away from the unit. And then you go into essential questions. These essential questions help govern each phase of the unit. So what points do you need to cover in order for the students to be able to have the skills necessary and apply them when they enter a summative assessment, for example. Now, the essential questions that I have listed on the screen: how does evolution occur? How do DNA, anatomical structures, and embryology support the theory of evolution? What knowledge or skills do I need in order to support a claim about evolution? How can I apply this knowledge to other scenarios? How does evolution affect the human world today? How do biases affect my opinion about evolution? Notice that it's my and I being thrown in these questions. That is because these are the questions the students should be asking, not that we should be asking. These are what the students don't know, need to know, what they will learn. And a great way of figuring out these essential questions is simply through a pretest. You'll see that as one of the assessment pieces that I have here. Now, there are some essential questions that come just from us knowing what we have to teach, especially the first two. So how does evolution occur? Students need to know that. So you need to teach them how does evolution occur. You need to teach them potentially about natural selection, about selection of specific traits due to the environment, due to a trait being preferred. So this is a good time to mention that I am unpacking a singular standard. That being said, as you could see with NGSS, there is more than one standard for evolution. There are multiple standards for evolution. There are also standards for natural selection. And this is a great way to combo standards. So a lot of educators see the whole list of standards and go, oh, that's going to take a while to teach. Well, in this case, this particular standard actually combos well with 4 different standards that I have not addressed. One of them being about natural selection and about how natural selection is a requirement for evolution to occur. Those standards I'm not unpacking through this demonstration, but I want to point out how you may need those other standards. You may need to apply those other standards when you're completing the essential questions. If some of your essential questions come up and it looks like it's not enough, this one standard isn't enough to cover what you are getting from these essential questions, then go back, look at the standards, and apply it to the entire unit. A unit can have more than one standard. A unit can have 5 standards, especially if it's a longer unit. For example, at the high school I taught, 5 standards were typically used per each unit. So for this unit on evolution, we had 5 standards, and they all connected together, and they all had similar essential questions, enduring understandings that we wanted the students to take away from this. So if you are faced with an issue of you have to meet every single standard in your curricular year, then find ways you can group standards together that help to make sense of this entire concept. For science, it is divided up into life, physical, earth, and space. And so we can really start grouping standards together, especially in regards to structure and function. There are about 4 standards that govern structure and function. There's another 5 for transfer of energy in ecosystems and photosynthesis and cellular respiration. Another 5 for interdependent relationships in ecosystems. Another 5 for genetics and inheritance of traits. And at the end of the day, when you look over the calendar year and you see what you have done from September all the way to June, you can see that you have met the standards. You just need to figure out where they can be grouped together. So moving on from essential questions, we now can get into how the unit is going to look out over a span of time. Here are the test specifications for this unit. Again, as I said, you can have multiple standards in a unit. So this test looks a little small. It's 10 points and they're all multiple choice. Typically with exams, I tend to not use multiple choice items, or if I use multiple choice, it is very apparent why I'm using them. I tend to use written questions. And the reason why I use written questions is because that is the best way you can ascertain if a student has mastered any of the objectives. I find that if I am using multiple choice, it is basically who was able to guess correctly, who was able to cheat their way through a system. And that's not my goal here. My goal here is to get the students to meet the standard. So that being said, noticing that the unit is shorter, I want you to look at the 3 objectives that are on the screen. When presented with evidence, interpret the evolutionary connections between species. When presented a scenario, analyze a population to determine if evolution occurred. When presented with a scenario, support a claim to explain how a changing environment can lead to evolution in a population. So, those 3 objectives increase in the cognitive level as you go down the objective. This is according to Bloom's taxonomy. So this is higher levels cognitively. That means that the students aren't just remembering, they're not just understanding, it's not just a comprehension. It is the student can analyze, they can apply, they can evaluate, and potentially even synthesize. However, that's not a specific objective here. I only have 3 objectives for this particular standard. There can be more though. There can be a lot more objectives. As I said, you can have more than one standard. So if you have more than one standard, chances are you end up increasing your number of objectives. So within a particular unit on evolution, I would have 4 standards, which means that I would have about 14 objectives depending on each standard and the length of each standard. I have more questions for evaluating than I do have for applying or analyzing, and that's because ultimately, as stated in the standard, I want them to be able to evaluate, support a claim. I want them to be able to say, this is my claim, this is the evidence that's supported, here's my reasoning. Now, in order to reach that goal in that summative assessment, we have to actually create a curriculum map. So, as stated, we're working backwards. So we have an idea of what the test is going to look like. Now we have to work through how do we get to the test. So we started with the standard. We discovered the enduring understandings that are needed for a standard. We've went over essential questions that are needed for the standard to progress. We looked at what the test is going to be, what the summative assessment is going to be like. Now we are going to look at the curriculum map. So the curriculum map has the learning objectives stated. It has also a description of the unit, the ultimate goal, what we want the students to know, understandings in there, and we also have some of our essential questions up on the board. So in the first column, down towards the bottom, content and or essential questions, I have how does natural selection encourage intra and specific diversity over time, structure and function because we're looking at anatomical structures. We also have inheritance of traits, and that's proceeding from a unit previous. Common ancestry, so the students have to understand what a common ancestor is and how common ancestry is determined, and also evolution as a whole. How does evolution occur? How does environment cause evolution, etc. This unit is stated as 1 week, so 7 days, with the very last day being a summative assessment. Now, that being said, for this 1 week, sorry, not 1 week, 1 school week, so 5 days, I would not teach a 1 week unit on evolution. This would be a 5 week unit. This would take up a good month and a half, maybe even 2 months. And that's because I would include other standards. I would include more objectives. So this really gives you an idea of how much time you have. That's what this part of our whole unpacking the standard is dedicated towards, is mapping out what assignments are you going to give, what assessments could be given, what activities you could give, any resources you would need, and also the knowledge and skills that are produced as a result of this. So for knowledge and skills, analyzing and interpreting data, developing and using models, cause and effect, scale, proportion, and quantity, science as a human endeavor. So those are skills that I want the students to be able to have. Those skills can go across many different units, not just this particular unit. It can go into genetics, if you're doing math, probability, it, English, reading a text. So those can be carried over from unit to unit, essentially building skills. Suggested assessments. So I like to have some kind of a pre-test the very first day. That pre-test usually looks similar to the end test, I will say that. And that's because I want to be able to see what my students can do before I teach a unit and what the students need to know during the unit, need to learn during the unit in order to get to a higher goal, and then ultimately what I have taught my students. This is very typical of standards-based grading, which is what my school was moving towards, was standard-based grading. For the entire week, I would include some kind of formative assessments. Formative assessments vary depending on what you need. I usually try to have some kind of a performance task that the students can accomplish during the unit. And then, of course, I have a summative, which is the end of unit assessment. I also like to include in reflection pieces that the students can use, reflect on, and observe and uh, explain what they have learned. Typically, I have an opener, and I usually have discussions to close out units. So for my opener, I have The Evolution of Anxiety. It is a fascinating read in which it discusses about how humans evolved anxiety. And that relates to our fight or flight reaction. I like to use different resources from popular science education sites such as HHMI. Nova is a great one. Nova is excellent, actually. Their PVS Evolution, very good for the kids. It's kind of like a game, and the students have to be able to uh, successfully create a phylogenetic tree. And if they don't, it beeps it out, and it's a very fun sound for the kids. But besides it being fun, it also helps them to realize what traits organisms share, the DNA that they share, and also how to be able to read those trees as well. So this activity that I pulled is one that I've used before. It's HHMI, lizard phylogeny, and that compares the DNA of different lizards on the Galapagos Islands. In addition to that, I have examined different pieces of evidence to support the claim that mammals descend from the same common ancestors. That is in relationship to the performance task, which is gel electrophoresis. And it's also in relationship to a different assessment that I tend to include, which is evidence for evolution stations activity, where students walk around and look at different stations. Those activities can change, the assessments can change. This is all just mapping out what your unit should look like, what you should prepare, what you should have. And what you want to do is have the assessment and see if it matches up to a specific learning objective. If you include an assessment and say, oh, that's great, that's about evolution, I can include that here, but it doesn't match up to your learning objectives, then why are you including it? It's more of a filler activity then. That being said, it is easy to match up assessments and to specific learning objectives. So, for example, that lizard phylogeny, interpret the evolutionary connections between species. For that as well, it's looking at populations and evolution. There's also another one that HHMI does for natural selection, and that has to deal with the finches on the Galapagos Islands, and that's an excellent one to do. So from there, let's delve into a little bit more detail about other assessments as well. So as I have up on the screen, there are a bunch of assessments right there. So a pre-assessment, evolution of anxiety, evidence for DNA stations, HHMI, lizard phylogeny, gel electrophoresis lab, and a summative test. Notice how it increases in difficulty and requires more skills. This is how I typically design units, is that we start off with reading or ascertaining information from text, pulling that information from text, and then we have some kind of hands-on activity. It doesn't have to be involved or require a lot of materials. For evidence for DNA stations, I print out, for example, I print out a bunch of similar DNA and I say connect these pieces of DNA and determine who is more closely related to who, and then write a reasoning supporting your claim that a lizard is more connected to a toad than to a human. HHMI is done online and through and on paper. They have excellent activities, and I always suggest looking for activities like this, and that is because students become much more involved. They're much more able to focus when you have a unit like this, when you have more interactive activities. So I don't necessarily have a lecture. I don't have, okay, you have to follow this PowerPoint and do this, this, and this. Instead, I'm having them read, I'm having them participate in activities, and those activities in of themselves tell the students what they need to know. They show that, hey, the DNA between these two species is closely related. If it's close, if it's closely related, then do they have a common ancestor? Yes. Why? Because the DNA is similar. There is a great simulation that is on the Concord Consortium called Geneverse, and that's a very good way to have students learn about meiosis, learn about Punnett squares, learn about genes on chromosomes. And when you use stuff like that, students will become more engaged, more active, and also students have a built-in connection that they didn't necessarily have before. I do like to end units with some kind of a lab. So in the case of evolution and natural selection, I would end with a gel electrophoresis lab. Gel electrophoresis is essentially applying a current to a gel. Gel sounds exactly how it is. It's basically jello that is encased. And you run a current through that. The DNA spreads out according to specific charges on the molecules in the DNA. It spreads out. And what you're left with are essentially bands and patterns on the gel. And we use that to compare between multiple species of animals and determine who's more closely related to who, and then we create a phylogenetic tree. That is a performance lab. That is something that the students during the entire time have to do, that they have to be able to master, and they show me what they know during the entire lab. They have to write a procedure, they have to write out materials, they have to write a conclusion. That is a very detailed lab. That lab typically can take a week, especially if you have students who struggle with writing and you want to help them build up their writing. That lab can take about a week. So keep in mind that this unit would theoretically be 5 days. You definitely have to adjust according to what you need, what the students need. And then the last assessment is a summative test. It is what I like to call the end all be all. Typically with summative tests, I like to have quizzes before summative tests. So like I said, this is only a 5-day unit. So for this 5-day unit, um, it would essentially be big quiz, small test, as I like to call them. And in big quiz, small test, there is a lot of multiple choice. When you have a big quiz, small test, there's not a lot of room for writing, and it's more about them, the students, showing what they know through that small summative assessment. Okay, now the very last thing is to pilot the assessments, is to pilot the unit. This is definitely going to happen as you're teaching, as you're exploring your units. This is not a simple pilot. It has to happen with real students in the classroom. So this is difficult to do when you're not teaching evolution. For example, at this current moment in time, I'm not teaching this, so I cannot pilot this. However, you can see what assessments work, what don't work, simply by offering it to some students and seeing what they struggle with. And you could theoretically have a summer school and use this as an opportune time to see, okay, what do I need for a summer school class? And how could I apply that to a full year regular class? When you're piloting a unit, you want to make sure that the students are able to answer the exact same way as they did before. That means that if you give a end of the unit test and the students answer that test, they should be able to answer the exact same way the next day. If they can't, or if there's a question that they keep flip-flopping between, then you have to look at that question and see if it is valid and if it's reliable. If it's not valid or reliable, then you have to redo that question in order to make it valid and reliable. All assessments should be valid and they should be reliable. If the assessment isn't valid, if it's not reliable, then you cannot accurately demonstrate student mastery. When you cannot accurately demonstrate student mastery, that's when you have conflicting data. And while the students aren't pieces of data, you use that data to help your students. You use that data to influence how you design other units and how you map out the entire year. So make sure your assessments are reliable, make sure they're valid. My suggestion is when you create the unit for the first time, at the very end of the unit, have some kind of a reflective piece that the students can write so that you can see what worked and what didn't work from the student's eyes. There are some assessments that demonstrate mastery, and the students are able to demonstrate mastery through the assessment, but they did not necessarily enjoy it, or there were some difficulties along the way that you weren't aware of, but the students had. So offer those reflective pieces during the units. Document any struggles and opportunities to venture outside of the classroom so that you can include those in other units, or if you teach the same unit the next year, have it so that that's included as well. The main goal of creating a unit is at the very end to have the students meet the standards that were assigned to that unit and to have them also have those enduring understandings that you wanted them to have at the very beginning of the unit. So we've essentially been working through backwards design using Wiggins and McTeague. And this is an effective way to be able to see how you need a unit to plan out for the entire unit. Through backwards design, you're able to see a clear end, and then you can see a clear beginning, and then you can flesh out the middle, which is what these last few slides have been about. So with that being said, this is my reference, Wiggins and McTeague, Understanding by Design. It's an excellent read. You can grab this book from any shop. It is a book, and you can read it and see backwards designed, explained potentially in other areas, such as in English or in mathematics, than what I've done with NGSS. One of the struggles I had when I was a student teacher was that I didn't know how to work backwards. I didn't know how to create an assessment before I taught students. I was able to develop that ability during my first few years of teaching and continue to develop that ability as I became basically a one-man band where I don't have other science teachers to help me. I just have myself. And I'm actually in charge of other science teachers and making sure that they're aligning to units. So I hope you found this demonstration helpful. I hope that this will assist you when you're writing the EdTPA, when you're writing different units, and please let me know if there are anything that I haven't addressed, if there's any questions that I have not addressed. Please let me know what I need to do to perfect this. I enjoyed speaking, and again, I hope that you enjoyed this demonstration. Please leave any comments or questions in the discussion section below. Thanks again. This is Patricia Nero from the American College of Education for Aligning Curriculum. Thank you.